So in this video, we're going to talk about how to describe the domain of rational functions. So rational functions are the ratio of two polynomials. So you'll see that rational functions look like fractions, where we have an algebraic expression in the numerator and an algebraic expression in the denominator. So since we're talking about functions that are fractions, these functions will have domain restrictions. And the reason for that is because we cannot have a denominator of 0. So you can see here, I have the rational function g of x equals x minus 3 over x plus 1. So notice what happens in this graph. You can see the graph is like in two pieces, right? That's because at that value, x equals -1, that will make my denominator 0. I actually have what's called an asymptote. And we'll see asymptotes a little bit later on in this unit. But what happens is the graph is going to get really, really close to that x value, but never actually equal it, because we cannot have a denominator of 0. So what we're going to do in this lesson is we're going to learn how to figure out where these domain restrictions happen in our functions, okay? So in order to do that, what you're going to do is you're going to take your rational function and set the denominator equal to 0. And then we're going to work on solving for x. So sometimes this is going to require us to actually factor the denominator first in order to be able to solve for x. So let's look at this example and determine what values are restricted from the domain of f of x. So all I need to do here is look at the denominator, okay? So my denominator is 4x plus 20. And so what I'm going to do is I'm going to set it equal to 0 and figure out which x values are going to make my denominator 0. Well, this is a linear function, right? So I can just go ahead and solve it one of two ways. You could either factor it or you can just solve it like you normally would. So since we're going to get into some factoring, I just want to solve by factoring. So notice that both of these are divisible by 4, right? So I can just go ahead and factor out the GCF of 4. And so that's going to leave me with 4 times 4x over 4 is just x, and then 20 over 4 is 5, right? So now I can divide both sides of my equation by that 4, because 0 divided by 4 is just 0. So I have x plus 5 equals 0 divided by 4, which is 0. And then now I'm going to go ahead and subtract 5 from both sides. And when I subtract 5 from both sides, I get x equals -5. So when I'm describing the domain of this function, I would say all real numbers, okay, except x equals -5. Okay, that's how you would describe that domain restriction. So now let's try this example. We want to determine what values are restricted from the domain of f of x. So once again, all I'm going to pay attention to is that denominator. Okay, so in this case, my denominator is a quadratic, so I'm going to go ahead and set x squared minus 4x minus 12 equal to 0 and figure out the values of x. Remember, when you're solving quadratics, you can use any of your favorite methods: quadratic formula, graphing, or factoring. My favorite method is factoring, so I'm going to go ahead and factor this. I need two factors of -12 that are going to add up to -4. So remember, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Since my b value, my -4, is negative, I need a positive and a negative factor, and I'm going to make my bigger factors all negative. When I make the bigger factors negative, the pair that gives me the correct combination is 2 and -6. Okay, so I have x plus 2 times x minus 6 equals 0. Now to solve for x, I need to go ahead and set each of these factors equal to 0 and solve for x. So when I do that, I just need to solve these two linear equations. Over here, I'm going to subtract 2 from both sides. So that gives me x equals -2. And then over here, I'm going to add 6 to both sides. And when I add 6 to both sides, I have x equals +6. So I would describe the domain of this function as all real numbers except for those two values, okay? So except x equals -2 and x equals 6. So that is our domain restriction. Now you can go ahead and pause the video and try doing this example on your own. So here, once again, I'm just going to pay attention to the denominator, which is x squared minus 2x minus 15 equals 0. You can solve this whichever way you'd like to. Once again, I went ahead and factored, and I got x equals -3, x equals 5. So all real numbers except x equals -3 and x equals 5 is how you would describe the domain of this function.